All right, so I'm going to be walking you through SPSS and using SPSS for Anova. So this is some data that is based off of a famous PTSD study looking at prolonged exposure, and Anova is one of the main authors of this original data looking at this. So I wanted to replicate this data as best as I could. It's not the real data, but just kind of show this process. So in this 1991 article, there were 4 groups in this study. So I have in this data set, this is under the variable view, we can see the values here for the different groups. So we had a stress inoculation group, a prolonged exposure group, a supportive counseling group, and a waitlist control group. So the second two are really control groups. The supportive counseling is having that contact with people, but without the therapeutic component. And stress inoculation and prolonged exposure are the more exposure-based type of treatment. So we have kind of two treatments and then 2 controls. We've got 3 time points. So that's one variable. That's the between subjects variable. So there are different people in each of those groups. We have a within subjects variable as well, and that's time. So we have 3 time points: pre-treatment, post-treatment, and then 6-month follow-up. So these are it's a pretty simple data set, but it allows us to do a lot of different types of things in Anova. So, and then here's the data. You can see this pre, post, and follow-up. This is a PTSD severity measure, and the higher the score, the higher the PTSD. So the first thing that we would do with any sort of data is to look at descriptives. So if I go to Analyze and Descriptive Statistics, and let's say I just want to see how people changed over time. So I'll pick the 3 groups, and I'll bring them over to this right side, the pre-post follow-up. I usually just click in these boxes to see what's there and just choose as I go. I might pick the mean, the standard deviation, the minimum, maximum, just to see if there's outliers. If I were doing this in a brand new data set, I'd spend a lot of time trying to look at the kurtosis, skewness, and some other things, but I'll just kind of keep it really simple for this analysis. So I'll hit continue, and I can change the style of the tables. I'm not going to do that for this video, but I'll just hit OK. And we get a very simple table. We've got 45 people, and you see the minimum and maximum scores here. It seems like it's what's in the range that we would expect. And then the mean of each time point. So at the pre-test, we have a mean of 20. At the post, we have a mean of 16, and follow-up 15. So it seems like people are going down over time. We also have standard deviation that looks pretty similar over time, which is going to be helpful for Anova. We want to have that homogeneity of variance component, the variances to be equal across time. So based on this, it looks like that. The problem with this, it's not that informative. We've got 4 groups that are all combined into these scores. So all 4 groups on average scored 20. All 4 groups scored 16. So this kind of gets at the main effective time. That we can see maybe people are going down. It's not an inferential test, but based on the means, we can see people are going down across time. But we don't know which group is better with this type of descriptive statistics. So let's go dive a little deeper. So in order to do that, instead of going to descriptives, which we just went to, I'm going to go to explore. And this allows us a little bit more flexibility in our descriptive statistics. So I did this right before I recorded the video. I've got my pre-test, post-test, and follow-up in my dependent list. Those are my DVs. And then factor, which is another term for independent variable, I have the groups. So I'll have, what I'm going to do is break it down by groups. So I'm going to get means for the different groups. So again, I can go through all of these options. You can click on as many things as you want, but I'm going to keep this rather simple. I'll run this analysis, and what I get on the top here is just how many people were in each group and how many cases were missing. This is made up data, so this is pretty clean data. I don't have that many people. And then I get the descriptive data. And so what I have here is the pre-test. I've got all of these statistics here. So here's my mean for the stress inoculation group. mean for prolonged exposure, supportive counseling, and I just keep scrolling down. This gives me all the data that I want, but in a very unusual form, unusable form. So it's hard for me to see the difference between groups and all of those type of things in this format. So what I do, and I feel like this is somewhat of a video game, I click on it a bunch of times and it opens up this box, and then this little bring this down to the screen, this little colorful thing, it's a pivot table control. And all right, so now it showed up. So what it does, it allows us to move our items from rows to tables. So one thing I might do is maybe move the groups to columns. And this actually helps us out right there quite a bit. So already looking at the table, we're getting our 4 groups right next to each other. That looks pretty good. I might also move this to columns, and it makes it look a little better. What I'm going to do though is move the stat type, and I just play around with this. This is just a kind of a simple way to do this, but I just kind of keep moving things around, and I kind of figure out where to put what columns until it looks right. But when this looks pretty good. So this is a little bit better. Actually, let me. All right, so now we've got our groups up here. We can see that on the pre-test, they're all about 20, 20.34, 21.47, etc. Post-test, scores go down quite a bit. We see stress inoculation goes to 13.93. Prolonged exposure goes to 13.3. The other two are still pretty close to 20, didn't go down as much. And then follow-up, if I scroll over, we can see the scores for follow-up. So this is a little bit more helpful. I'm going to show you an even better way to display the data in a second, but at least this with the descriptive statistics helps us out quite a bit. So let's just kind of move on then. Let's see how things change over time. So what I'm going to do is go to compare means, and we have 3 time points. So I can no longer do a t-test because that only measures 2 things. So I have to go to some sort of Anova. So I can look at a one-way Anova and look at the differences between groups. And so that's one way to do this, not the reason for the one-way and the Anova. But I don't really care about the differences in groups because I need to break it down by time. So I have to go to a little bit further. I can't use the one-way Anova in here. I go to repeated measures. And this is a little bit of a confusing thing in SPSS. It says factor, the within subject factor name. So within subject says time. The same people are measured 3 times. So I like just to call this time. I kind of wish this was just the default for SPSS to call it time. It would probably simplify things for many people. There are 3 levels of time: pre-test, post-test, and follow-up. So time, 3 levels. And then I'll go to define, and it will have my 3 time points. So I'll drag these 3 over to here. And so with this, I could see, is there a change over time? But I'm also interested in, is there a difference over time for group? So I'm going to bring the between subjects factor of group over here as well. So if I left this out, I would just see the combined effect of change over time, which would maybe say that overall these treatments work, but I don't know which treatment works better. So by bringing group over, now I can start to look at which treatment works best over time. Some things there's a lot of things that we might want to change in here. I'm going to just kind of keep it simple this first time. I'm going to do a plot, and what I'm going to do is put time on the horizontal axis, because that's a common thing. We look at time and we look at it from left to right. So I like that on the horizontal axis. And then I'm going to look at groups. Each group is going to be a separate line plotted across time. So what I do, I put those 2 things in there, and then I hit add. And so this is going to make a new plot for the groups going across time. I'm going to do this one too, just one to show time. This is going to combine all the groups. This is not going to be a useful, well, it doesn't look like it can actually do it by itself. So forget that. So I'm going to just do this time by group. I'm going to do it as a line chart. This is a new thing. I'm going to include error bars too. Let's see what happens with this. So I'll hit continue. I'm going to want to eventually do some contrast and post hoc test, but for now I'm going to keep the model as simple as possible this first time around. So hit OK. And this is our repeated measures ANOVA. So at the beginning we know what our within subjects factor variable is, what our between subjects variable is, how many people are in each group. This is the multivariate test. This is if you have problems with sphericity, which is kind of analogous to our homogeneity of variance, but because it's across time, we've got the sphericity factor. So if we have a problem with that, we can use these multivariate tests. So I'm going to come back to that if we need to. What we've got, the test of sphericity. They're saying there's a little bit potentially a problem with that. So what we have are correction factors with sphericity. The greenhouse geyser, Heinfeld's, and lower bound are all correction factors in this table. So what we can see is this table is pretty important to us. We want to look at the interaction first. So we want to see, is there an interaction between time and group? And actually, let me just show you in the figure. And then we'll come back to the statistics. So when we look at the figure, we can see these blue and green lines are our stress inoculation and prolonged exposure group. And they go down quite a bit at post-test and stay down at the follow-up. The other two groups, the control groups, kind of stay up and don't really go down all that much. So we have an interaction where these two groups are staying pretty steady and these two groups are going down over time. So we're looking for that interaction between time and group. And that's what we're in this figure. It looks like it's significant. Like there's a difference between the groups. These two groups that are the intervention really changed, and the two groups that were more control groups didn't change. So we want to find out if there's a statistic for that, and this interaction is what really shows us this interaction effect. So this time by group says, and all of these are significant. So with the correction, they're significantly less than 0.05, and without the correction. So we're pretty confident that even I would probably use greenhouse geyser, and just I can say that that we're not assuming sphericity, and we're finding a significant interaction between time and group. It could be all of the groups work equally well, and let's say we had 4 intervention groups, we might see no interaction, but we might look then at time. Is there an overall effect of time? Is there something changing over time at different time points? Is the score different? But here we're finding a difference between groups, so we look at that interaction. We don't have to look at this overall time effect. We want to find out this interaction, and we're going to break down what groups are doing better over time. So that's that. Now this is what's in default into SPSS. This is a way to look at what's happening over time and if there's a linear effect or quadratic effect. And this is something that's probably a little bit more advanced, but what we're seeing is that there's sort of a quadratic effect where we have an inflection point. What we need to do, though, is break it down a little bit more by group and look at how the groups are changing. But this interaction right here is really saying that there's a difference between groups and that some groups are changing more over time than other groups.